Alright, time for the DraftPhysics.com, DebatePhysics.com also, video presentation. So first, I thought I would just point out, I did a video last night regarding physicist Michael's kind of garbage, trash, shit comment. And I thought, so I posted a link to it just because, he doesn't necessarily watch all my videos, so I just wanted to make sure he saw this one. And so all I did was put in the comment something like, you are very unfair. There, that's what I said. And then I said response video. And YouTube wouldn't post the comment. So apparently you can't call somebody unfair. Even that's too much. Which is, it's just so ridiculous that you have to go through this crap. I mean, it's just ridiculous that we're living in a civilization where you can't do anything called a rational comment thread because your comments are going to be deleted or removed or invisible, and you're not going to be told why or anything. It's just this Google says you can't say that. I mean, it's so bad, and everybody's okay with it. Not everybody, but way too many people are just okay. Let's let Google decide what we can say. I mean, it's just amazingly retarded. So anyway, in the same, I will do some more pointing out of things. So I guess in this video, there's just so many raggy comments. There's so much raggy shit. These people are just such despicable liars. So anyway, I did find, I remember it was an old video I have shown before, but I thought I would show it again. It's a Newton's cradle. It's some sort of duplicating the free momentum experiment, but obviously without the free momentum part. So I thought I would show that. So I'll go find that first. Alright, this is so this is in slow motion. Maybe I should slow it down even more. We'll see how it plays. And so this is a 3 mass to 1, 3 to 1 relationship instead of a 2 to 1. So there's even more free momentum that's supposed to be created. So when the lighter ball hits the bigger ball, it's supposed to be creating maybe 50% more momentum going this way, and there'll be some reflection, so some momentum will go the other way. Now it's supposed to be a rather substantial, it's supposed to be like 50%. So you're supposed to get, like, say if this was, the little ball had 100, it's supposed to be that we're getting 160 going this way, and that we should be getting something like 60 in the other direction, or 70. So it depends on, they have math for this, but I mean, I don't think there's anything regular about the math. But anyway, this is the idea that I could go up to a maximum of 2. So if we thought of this bigger ball as a brick wall, the idea is that you can put a full 2 momentums, so 200 momentums going into the wall, and you get 100 back. So you make a total of 300 momentums, and you start with just 100. So it's the free momentum experiment, essentially. So let's see if we can see anything that looks like that. But this is going to create an oscillator. And the oscillator, just like the lever, is going to oscillate for quite a while, perfectly. And the argument is that oscillators, basically, it's kind of essential to their function that they throw all the energy one way and then they throw the energy back, and it oscillates back and forth. And so you can't have 3 times the energy in one side of the oscillator and 1 unit of energy in the other side, because it won't oscillate.
Process repeats on.
Alright, so we probably don't need the voice because it's really bad English. So that doesn't look like 3 times the energy. I mean, that doesn't look like almost twice the energy, let's just say, or 1.5 times the energy. It just went this way. So we got a little reflection, and we got forward motion and the 3 times the heavier ball. But this is the important part. You'll see it's a regular oscillator. So it bounces back, and the big one stops because it's got so much more mass, and the little one flies off with the substantial piece of the momentum. So it flies back further than it bounced the first time. So the first time it only went a little bit, came back. This time it went much further, so it's carrying the bigger piece of the momentum. Now it's going to come back and hit the other one. And it gave it now the bigger piece of the momentum, and it's got the little bit of momentum again. It's going a little distance. And then they crash into each other again, and now we're just going to get the big momentum. It's going to go into the, so it's a Newton's cradle in the sense that literally it's happening, where the energy from the one object is going into the other object. No matter what its mass is, it's basically saying, I'm going to take the energy of this thing, whatever one's bigger, more momentum, and it's basically going to transfer it to the other one, and the little momentum is going to get transferred to the big thing. So they're just switching identities, essentially. But you can see it oscillates perfectly, and there's no reason to believe that you started with 100 and now there's 300 momentums bouncing around in here, or 250 or 200. No good reason to think there's twice the energy than you started with. So you can see it just oscillates quite regularly. It's a regular oscillator. And we're supposed to believe that every time it hits this bigger object, it's giving it more momentum. When, no, it isn't. Yeah. So it goes on for quite a while. So anyway, just thought I'd throw that in. Obviously it needs more analysis. I mean, we need to do, whatever, some sort of stop action and frame rates and all that kind of crap. But frankly, it's not my job. And so physics is making the contention that there's a thing called mv squared. They should prove it with a real experiment and quit evading the subject. Alright, back. So I do have a ruler superimposed over this, and I suppose I could make this just even a little bit bigger. So let's try that. Just to make the measurements more accurate. So this first image in the row, in the sequence, is the one where you have the two mass going half the speed. Alright. And then there's a third series of experiments done with a two mass going twice the speed. Clearly by the 1/2 mv squared, if I double the speed, there's supposed to be 4 times the energy. So the spring should compress 4 times. 4 times the compression. So it should be 1/4 of the compressed distance. Now I've argued that the two ends here really aren't relevant, but we'll do it both ways. So the full length of the spring is 3, and it's almost 8 or 9. Okay, 3.8, something about there. So let's move this over. And so this is the half compression. So, this is twice the speed. Okay, supposed to be 4 times the energy. Twice the speed is supposed to be 4 times the energy. Alright, and so we have something close to 2 and some extra. Alright, so I'm arguing that if you look at these images, you can see that they're not very good, in the sense that they're not the same size, resolution. Alright, so that's 2 and a little bit, and that one's 2 and a little, almost 2.5, frankly. Alright, way short of 4. Okay, so yes, it's a little short of also being half the compression. It's supposed to be twice as compressed, and it's not quite twice as compressed. So it's really short of proving kinetic energy. It's a little short of being where I'm saying it's supposed to be. And again, I would argue that's because the resolution of these images is garbage. Alright, so let's just, for the sake of see if it makes any difference, let's measure from where the spring actually compresses. Alright, so the part that actually compresses is 1.7, we'll say. Alright, let's go back here, and so the part that actually compresses might start about there, and it's 3 again. So it's pretty big. Yeah, it was 3 plus extra before, so it's about 3 for the part of the spring that actually compresses. So 0.73, right? Isn't that what it said? Or is it 1.7? No, it wasn't 1.7. Let's just go back and check that one again, because I already forgot. All right. No, it was 1.7-ish. All right. Yeah, something like that. 1.7. So anyway, short of double the compression. But again, the images aren't the same size, as you can see. Now, if I could, I probably can turn the ruler around, but I really shouldn't have to, frankly. I mean, an honest person should be able to see that this height of these springs is not the same throughout these images, that this height has changed, that this is a lot higher and thicker because the image resolution is different. All right. So that's proving, again, that's a piece of evidence decidedly against their side. It's nowhere close. This is nowhere close to 1/4 the size of this. All right. So kinetic energy loses big time on that experiment. Now the comparison between these two. Now these two, you can really see the difference in the size of the spring. So this obviously is not going to be a fair comparison. And you can just use if you have any imagination, you can certainly use it and figure out that it really isn't fair. So we're figuring about 3. Let's see if this one's a 3 too. So that's where the compression starts, that's where the compression ends. So let's measure over here. Now, even though the image is distorted, like I said, I could blow them up and try to make them match, but frankly, not my job. Let's see if we have an image that isn't as too blurry to get a precise, so it's something about there. Alright, and so it's about 2 something. 2 and 2.3. So it should be 3 and 3. It's 3 and 2.3. Alright, indicating that, yeah, they should be the same, but this one appears more compressed. Now, it only appears more compressed because it's a smaller image of the spring. I mean, you can see the images are smaller. Okay, so I guess maybe I'll turn the ruler horizontal. I think I can get away with that. So I'll pause for a second. Well, that was fairly easy to do. Alright, so we'll measure how thick the spring is from top to bottom. Let's see, this is really big here. Yeah. Alright, so we'll just do one of these loops. Can't read the number. Alright, gotta move the image over. That's not the right thing, so I gotta move this over here. And then I gotta move the ruler back into the picture. Alright, technicalities. Alright, so 2.6 or 7 again. I mean 1.7. Alright, and so let's move the other image over. All this work I shouldn't have to do for regular humans. Shouldn't require somebody to do this crap. Alright, so yeah, I could just move the image to the 0, I guess. Well, it's probably better to move the ruler. Bump. Let's see, so I can get right on that line. Alright, so clearly like 1.65, yeah, 1.5 at best. So that's a center loop. Let's try one down here and see what we get. So at this spot, that one is 1.5-ish. So there's a 0.2 at least difference. But again, visually you can see not even close. I mean, this image is not the same as this image. They're not the same resolution. But you can see the thickness of the spring itself, not the same. So anyway, so clearly this is another example where even if it's slightly off, that these compressions aren't the same, it's nowhere near their theory. Their theory says this spring should be twice as compressed as this spring. There's nowhere near twice the compression, not even close. So again, they're saying that they've proven me wrong when it's even a bigger proof against their theory. An obviously bigger proof against their theory. And not even a very good proof against mine, in the sense that these photos are obviously of not the same quality. You know, it's obviously not. You can just see from the size of the crops he did that these obviously weren't cropped the same way. These photos weren't cropped to the same resolution. I mean, it's obvious from just the image sites themselves. So this is what they're relying on. So they're claiming victory on this kind of crap evidence. And that's what I'm up against. People who are this desperate to force the truth to be what they say it is. And this is how desperate they are, that they'll give credence to evidence this bad. I mean, not even close. This isn't close to 1/4, and this isn't close to 1/2, and it is quite close to actually being the same. Alright. So, just throwing it in and such. Alright, back. So PhysicistMichael did respond to another video on momentum, and so it was basically where I was pointing out, it's not the most recent video where I make it even clearer, but anyway, that you could make a Newton's cradle and try to do their double the momentum theory. So they have a theory that you can double the momentum. You can hit one mass into, say, mass X, where it is barely going to move. Okay, so it's almost too heavy to move, but it still moves. And the idea is this would go in with 100 momentum again, and I would get literally 199 out this way, and I'd get a reflection of 100 back. So I'd end up with a total of 300 momentums in the universe, and I only started with 100. So it's free energy, and that would be an argument against the theory, that the theory can't be true if it's predicting something we know can't happen, which is the creation of free energy. If free energy was this easy, we'd all have it. Alright, so I pointed out that I could create this very heavy thing, okay, that doesn't move, and that basically the one mass would just keep reflecting and bouncing back, and reflecting and bouncing back, and reflecting and bouncing back. And if we believe the Earth moved, because this solid object didn't, and it went through this hardware into the Earth, that I would keep moving the Earth. The Earth would move with 200, well, 199, let's be accurate. Okay, and the second time, you know, it would be 198. You know, because this lost a little bit of momentum. You know, the reflection is normally 99 back, so it's only going to be 99 coming in the second time. So the second time only 99 goes in. So now this is 198 for the second time, and then 197 and whatever. So, but the idea would be, as the Earth keeps collecting it, for every bounce back, the Earth collects twice the momentum, and so the Earth could theoretically collect 5,000 momentums from 100. I just start with 100 here, and I get 5,000 out here. So I made this argument kind of clear, you know, and it's just being evaded. Like all the other arguments. But the other way you could look at it is I could make this into a rotating, let's just say it's a gun, and I can, you know, rotate the bullets on the gun. So the gun has something here where I can rotate the bullets, and the bullets are a mass that will be you know, get that 199 thing, that it's going to be barely able to move, and just barely being able to move. And so I can rotate it with using very little energy to rotate the bullets. And so I just do the Newton's cradle thing. I just basically have the reflection is going to go into gravity, and I'm going to get the same energy back. Gravity will take it, and then gravity will give it back. So I'm going to get the 99 reflection this way. I hit the object with 200. Okay, so I have, well, 199. So the bullet leaves with 199, the projectile. This reflection happens. I come in with almost the same energy, 99 this time instead of 100. And so then I just rotate it, I send a second bullet at 198, and then I send a third bullet, whatever, 196, however it works out. You get the idea. I can send 50 bullets at, and I would put 100 momentum in. There's no bullet, like there's no charge here. The projectile is getting moved by the energy of this object. So by the object to keep continuously bouncing, I can keep doing this. Now obviously momentum says, no, if this moves this way at all, this isn't reflecting. You can't move this with a substantial momentum in this direction and still get a reflection off of it. If it's moving with a substantial momentum, there's no hope of getting a reflection. So if I throw a ball at a wall and the wall yields, that is, it accepts the motion, the ball's not coming back. And that's the argument he just totally evades. So, I'll read his comment, but it's just an evasion of the argument. Clearly, this indicates that the mv, 1/2 mv squared is in fact a free energy theory. And it's their obligation to show that it's not. They can't show that it theoretically isn't, so the only way they can show it's not is they have to explain what they claim to be the truth. They have to show how what I just said doesn't happen. And as soon as they say it doesn't happen, then they've debunked their own theory, because their theory says it has to happen. So they have to explain how their theory doesn't say that, when of course their theory directly says it. Okay. First, the positive part. Okay, this is a much better method of trying to disprove the textbook model. It's the same method, whatever. I'm trying to think of a better term than the model taught in physics textbooks. The better term is religion, because that's all it is. It's a bunch of unevidenced axioms stated as truth. The young double slit experiment is nail in the coffin evidence. That kind of hyperbole. So you could just call it hyperbole. Okay. The standard hyperbole, where you take a tiny little similarity and use it as an excuse to say something quite definitive and absolute. Okay, I agree that you can show that the principles of a model show self-contradictory results. That's a critical problem. So the contradiction is that obviously free energy is not a thing, okay, and it's just garbage and nonsense, frankly, to support a theory that has it as part of its declaration of truth. Okay, I mean, this was the same. Look, the first arguments made against Leibniz and his his mv squared, was that it's a free energy theory. That was the argument against it. It would mean there is perpetual motion. And let's understand, a lot of these guys still were looking for that back then. It means perpetual motion, and it means free energy. Okay, and that was exactly the argument made. That the physicists of the time did what I did, the logic, and they said both of these theories can't be right, because if momentum is conserved, your theory means there's free energy. Okay, you also seem to have made more of an effort to fairly represent the textbook model, so I'm not accepting your accusation that I have ever unfairly represented. So fuck you. I mean, it's just okay, and not straw man. Where's the straw man? So again, you keep making accusations, and as I asked you before, you don't have evidence for the accusation. You claimed I deleted a comment. I didn't delete anything. You didn't have any evidence. You're just making accusations. And I've asked you before, if you're going to call me a liar, or you're going to say I distorted something or perverted it, well then quote it, fucker. This bullshit where you make this fucking accusation and you don't back it up with any facts. How scientific is that? Oh, I guess it's perfectly scientific. That's the whole accusation, that your science is based on no facts. You won't show the evidence, which is appreciated. I don't appreciate it, frankly. I don't appreciate this nonsense that I have done anything unfair in these conversations. Screw that. Shove it up your own ass. Okay. So I'll give a detailed response here. Oh, I get the privilege of a detailed response because somehow, in some indistinguishable way, the drawings in this video were somehow better than the drawings in this video. No, it's that I'm not responding in the video to your rude accusations. So it's really, that's all that decides the temper of the tone of the video, is just how rude your accusations are. Alright, anyway. Here are a few things, here are a few of the key things that I think are missing. So again, more accusations. Okay, you're on the hot seat. You're the one who has to explain. All right, not me. All right, you're the one missing something by my accusation. Missing it in a big way, by the way, a huge, giant miss. Like you're missing the idea that you should have actual physical evidence before you tell me something's true. All right, in your analysis. Okay, so here we go. For the Newton's cradle with the extremely large mass, so there was 2 points made. One was if it's unmovable, that is, it doesn't move, it gets hit, it's an anvil, it's hanging there, you hit it with a P. It's not going anywhere. The energy isn't traveling to the earth. It's not going to happen. Alright, as you increase the mass, you get less and less motion in the object. Yeah, well, the argument is you're getting zero motion in the actual object. It's not moving. The tension in the string is going to increase similarly, yes, in a direction that has nothing to do with going that way. Okay, it's going down. That's it. Okay, so even though there is only a small angle deflection, so there's no angle deflection if it doesn't move. So by definition, if it doesn't move, just like the Empire State Building's not going to move when I throw a tennis ball at it, if it doesn't move, it doesn't move. I mean, that's just a fact. And you want to pretend it did move? Well, you're pretending it did move because you're not going to show it moving. You're not going to show Manhattan moving. You're not going to show the Earth moving. So these are all just your statement that it moved, even though we didn't see it move. Alright, in the string, and the tension will have gotten so high that the horizontal part of the force will still be significant. So it all says you. You don't have any experiments showing that to be true. So, says you. Okay. It would be like if I'm multiplying two numbers. So he has to make these analogies. There's always some sort of, if I bet on the number 3 on a roulette wheel, I'm going to probably win if I don't bet on 533 because 533 isn't on the wheel, or some kind of bullshit. One that keeps getting bigger and the other keeps getting smaller. Like if I multiply 2 times 0.5, then 4 times 0.25, then whatever. How those are small numbers combine and still give a horizontal impulse. So you're saying there's a horizontal impulse even though it didn't move. Fine. I say you made that up, but whatever. That impulse will transfer through the string to the support structure of the pendulum to the earth, and that momentum transfers to the earth. Okay, so in the other video where I demonstrated this further, I pointed out that that means I could put 5,000 into the earth. I can have 100 momentums, have it do a bunch of bouncing, hitting, and the earth will keep moving. So there, your theory is debunked. It's been falsified. Alright, for your hit versus push distinction, so I pointed out how the problem is with these experiments is making the spring transfer its energy efficiently. And so I talked about the difference between something hitting it and something pushing it. And instead of just saying, yes, I agree, it makes a difference, he's going to try to defend that hitting doesn't change anything when clearly it does. Reflected energy means that the energy isn't going into the object, and it means the object is leaving. And it means that the spring is going to keep wobbling after you're done. I said that in the video. And that wobbling after you're done means it didn't get its energy into the object because something broke down in the process. And so there are ways to see if the energy was completely transferred or not. That will affect where the energy goes. If it's elastic, then it normally absorbs and then releases back the Ke. So the whole point is that, as I've pointed out in previous videos, this is energy moving in a direction. That's what we're measuring. And anything that makes the energy leave in some other direction, that is, you heat stuff, you're moving stuff in other directions, all that's losses. So the idea is to try to keep the energy in this motion, to keep all of the fish going this way and not let any of the fish hit rocks and go the wrong way. It can be compared again to electric conductors, and you can understand that if there's dirt in the conductor, that actually that would mean that energy hits it and goes in some other direction, and that's not what you want. Okay, that's resistance, that's heat, that's loss. Okay, but it actually doesn't affect momentum conservation. So obviously I'm saying it completely does affect the transfer of the momentum. So the fact is you have to account for it. So if the spring isn't very efficient in contacting, just like an inefficient electrical contact, you're not going to move your wattage. So I think this is, again, just a non-response. You're not dealing with the actual subject that you can efficiently and less efficiently push an object. You can push it very efficiently or you can push it very inefficiently. It's a real possibility. All that is required for momentum conservation is that all the forces are internal. So again, that isn't going to work in terms of your directional conservation. You're trying to conserve the direction of the motion. You can't conserve the direction of the motion if you are creating heat or you are creating movement in some other direction. So all of the action-reaction parts of impulse cancel. So again, more nonsense about canceling. Nothing's canceled in any of this. You can't cancel the energy and transfer the energy. Can't do both. So more babble, in my opinion. Those internal forces can be literally anything, whatever that even means. Direct contact hits, springs, rusty, high friction springs, magnets, anything, as long as the forces are all between the objects included in the system. And again, so you're just talking out of some idealization. The fact is, I can hit something inefficiently. I can push a plunger into something. The plunger has its own mass and velocity. It can hit the object, move the object, start moving it, okay, but it is going to go back, and that means it's going to bounce into the spring that's trying to go forward. And so the two forces are going to conflict with each other and likely create a loss of the energy. So when it bounces back and hits again, it's not going to bounce back with the same force because it lost some of the energy to a bunch of other directions. So you just ignored the argument. All right. Between the objects of this, okay, as long as all the forces are all between objects included in the system. So again, if you're creating heat, those aren't objects in the system. That's, microscopic movement in the wrong direction. This is a point that I'll emphasize in an upcoming video. Well, that ought to be worth a laugh, frankly. Alright, for your spacecraft idea, so I pointed out that I could make a spaceship. Alright, make one side, okay, I'll draw it again, what the hell. I didn't realize I didn't have the text on the screen, but you could really live without it, frankly. It's not going to help you much to read along, because you can't really see it anyway, so who cares? Alright, so the simple argument is the implication of their theory is that if I could make a spaceship with a reflective side, so we'll draw that as this, and then I could make another side of the spaceship that was absorptive. Okay, so we'll just make that lines in it. So this side absorbs, this side reflects. And you had the same kind of energy moving in the system. That the fact would be is that this reflecting side, the side that bounced it off, ends up putting 2, okay, x the power this way. And this side, the absorbent side, the side where it sticks, okay, only gets 1, x, whatever the momentum of the particle is. So obviously you'd start going this way. And obviously this side would collect a bunch of stuff, but as I pointed out, you could easily just scrape that sideways. There's no force stopping you from just pushing all of this stuff off. So you don't get heavier and heavier. Now the fact is as you go faster and faster, you're going to bang into more stuff this way than this way, and so it's going to slow you down. So I shouldn't have said you could go to infinity. So I made that little mistake, frankly. But the fact is this thing would end up going really fast, really quickly, because everything hitting from this side is twice the energy that anything hitting from this side has. Now, he's going to bring up the radiometer, okay, which is that little famous thing where they try to do this, and it doesn't work. So if you put it in a complete vacuum, okay, it fails. Because essentially the only way it can work, okay, is they have to put a catalyst in, which means there has to be some atoms in there. And what those some atoms are going to do is basically create a greenhouse effect on the surface. So the energy needs to be filtered by an atom. The energy's intensity has to be changed, and then it has to reflect when it comes back up. So one kind of energy will go in, and the other kind will reflect off the same molecules. So you're basically creating a greenhouse effect in front of the surface. So without extra molecules in the environment, it won't spin. So it's just kind of proving that this is more fallacy of theirs, that this actually happens, or it actually works, because it doesn't work even on the photonic level. All right. So this comment by him wasn't quite as irritating. It didn't get really irritating, okay, until after what I read the other comment on the other video. But anyway, for the spacecraft idea, you're definitely not going to go faster in an unlimited fashion. Okay, fine, just say that. All right, since as soon as you start to move in a direction in a non-reflective side, increases the relative velocities of the collisions on the other side and decreases the relative velocities, right? And that only happens when you get up to like thousands of miles an hour. Eventually eliminating any advantage you generated, right? But that wouldn't happen until you're going thousands of miles an hour. You have to be going fast, at least half as fast as the particles are moving. So we're saying these are pretty high-speed particles, so no problem. So then he does an example, which I really didn't need. For example, if you're eventually going faster than the particles trying to hit and reflective side, there's going to be no more hits on the side. So yes, you'd have to be going very fast, faster than the particles, yes. Unless some energy source on that side is speeding them up, but that would be our source of additional energy. Well, I suppose I can make something to reflect all. See, I'm not even counting all the energy you're reflecting off the reflective side, so I can have it actually bounce back into the surface. Frankly, I just put another surface, and then it bounces back. All right. Anyway, depending on the details of the particles that are hitting the sail, I don't know if you're envisioning photons of light doing the hitting or cosmic dust or something. I was just pointing out how if I build a device that has these mechanisms in it, BBs even, some sort of non-stop little bits of energy, and I put this in a vessel, that the object will move right across the vessel by your theory. I'm just pointing out that your theory makes a propulsion device. That's what it does, a free energy propulsion device. That's the consequence of your theory, and you're just evading the point that, yes, that's exactly what the theory says, that I can make a free propulsion device, whether I take advantage of cosmic rays or photons or electrons, or it doesn't matter. Any one of them will do. All right. That's also going to heat up the sails. Well, you only get heat if you're changing the direction. So if the thing is made to just absorb and reflect, where's the heat? There's not going to be a tremendous amount of heat. Okay. And the thermal radiation from the non-reflective side would further slow down the sail. So why would there be more thermal radiation on the side that's doing the absorbing? The side that's doing the reflecting seems to me to be in bigger trouble. there's more energy being produced. So why wouldn't that be the hotter side? This kind of reminds me of a Crookes radiometer. I know, unfortunate name. I don't know if it's that different, but anyway. But I think the mechanisms are a little different. Well, I think the mechanism is exactly the same in the sense that it doesn't work. The theory doesn't work. Photons don't do it. The absorbent photons have the same energy as the reflecting photons. There's no evidence that it works. So it's just pointing out how this reflection thing doesn't work with photons anyway. Because I have to have the atoms in the environment to create a filter to make it work. Okay, for details on how thermal radiation is produced by the two sides and transferred between the two sides, which have different material properties. Yeah, one's reflective, one's absorptive. I'm not sure of, and would need to look into this some more. Material science is not my area of expertise. Well, you don't need to be a material science expert to know one thing. The fact is, it doesn't work with a complete vacuum. And the second thing is, it's just a shiny surface and a black surface. It's not very complicated. But we certainly wouldn't get the unlimited speed you describe. So again, yes, it was my bad to say you would just keep getting to infinity. And I barely said that, by the way. I basically was just making the point that you're going to go very fast, very quickly. Okay. So again, complete evasion. Alright, for the explosive case, so the point made for the explosive case is just the idea that if I can double my momentum with these materials, then I could just put a layer and then make the layer twice as heavy and then another twice as heavy layer. So little BBs, bigger, 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 bigger. And I got 6 or 7 layers, and by the time you get through all those layers, I have increased the power of whatever I put in 100 momentum. So I create an explosion that creates 100 momentum. It hits that surface and increases to 200, and then 400, and then 800. So I just keep increasing the amount of energy of the explosive pressure by just layering the bomb correctly. And there's absolutely no indication of any such material being used or any such idea being capitalized on, because it frankly doesn't happen. That's why we don't have it, is because it doesn't happen. Alright, for the explosive case, the amount of damage a projectile can do, how much it can break intermolecular bonds as it smashes through another object, things like that, depend on the energy. So, no, it doesn't. So I'm just going to say no, it just depends on the fact that high velocity obviously requires a bunch of energy to be transferred very quickly, and objects can't do that. So glass can take a lot of pressure, but it can't take it quickly. So you can make a high frequency sound and break the glass. Not the momentum in the textbook model. So who cares what the textbook model is? That's the whole thing being critiqued here. But let's consider your case of a series of masses with increasingly doubled mass. I agree with your description of what happens to the momentum of each of the next objects. So he's conceding the point that this is a free energy mechanism. The next doubled object would have a momentum with a magnitude 3 to 4 times the original. So you're conceding I can make this free momentum, but you're saying momentum isn't pressure in a bomb? Of course it is. But anyway, let's look at the numbers, starting with the 1 kilogram object moving 10 meters per second. So we don't need to do this number thing. We already know, yeah, you're agreeing. The momentum will go from 10 to 13.33 to 17.78 to 23, so ending at 31.6 kilogram meters per second, or 31.6 foot-pounds, you could almost argue, of momentum for the final 16 kilogram object. Big increase. So if this model is right, why wouldn't this method be used? So it's so funny. It's your model. This is your prediction. I'm pointing out that your prediction is creating this mechanism of free momentum, and it's clearly not being used. So it's clearly not happening. That's the whole frickin' point. I mean, it's just an amazing evasion. Big increase. So if this model is right, this is your model for free energy, why wouldn't this method be used? Well, it's the same reason why people aren't using levers to make free energy. It's because your theory doesn't work. All I can do is transfer momentum. All I can do is convert momentums. I can't make your free energy. Oh, amazing. Well, to start, let's see, the explosion. So now, I don't know exactly. He's not saying, I guess it's the same continuation of the explosion argument. Look, who cares about the start? I already pointed out it starts with something that has 100 momentum. We're just giving it a number, an explosive device, bang, and you're increasing it. In the textbook model where the explosive is initiated by an explosion or a compressed spring or something like that, we have a certain amount of starting energy. That's my whole point. You have a certain amount of starting energy, you put 100 into your silly experiments, and then you get 300 out. Okay, that's a violation of conservation of energy. That's a non-starter, okay, as a theory. If that's what your theory suggests, it's already broken. If you're suggesting non-conservation of energy, you're already in trouble. Not starting momentum. So I don't know. Something like we'd have to have a certain amount of starting energy, not starting momentum. Everything you could create as kinetic energy has to have a momentum number. It's built into it. The MV is built into it. It has a momentum number. So let's not pretend momentum, there isn't a number. There's a number. There's a real momentum. Alright, and the argument is your kinetic energy is fake, and the real momentum is the real number. You're saying your kinetic energy is real, and the momentum number is fake. But there is a number. In this example, we started with 1 kilogram object moving at 10 meters per second, so our initial energy would be, exactly, so you're saying it's 50 joules, I'll say it's 100 momentums. What's the difference? This is going to solve the problem. Okay. If we would have just started by giving the final 16 kilogram object this energy, how much momentum would we have started with? 50, he says. I don't know. I mean, he's just clearly evading it now through mathematical manipulation, trying to pretend that if I believe in kinetic energy, it conserves kinetic energy. Well, yeah, if you don't believe in momentum. I mean, Jesus. Give the initial velocity of 2 meters per second, so the momentum would be mv to the 40 kilogram meters per second. So now he's changing how much the initial explosion has, which is higher than what you got at the end of your method. Yeah, it's a free energy formula. I don't know how many times I have to keep saying that, but yes, yours is a free energy formula. If momentum's right, you're creating free energy. So it would be better to just put the energy into the last mass to begin with than go through the multiple process. So this is just a gigantic evasion. You're creating free momentum. You're saying momentum doesn't mean anything. I'm saying obviously momentum is a real substance in the universe, and you can't make it free. You can't generate it out of nothing. But as I mentioned earlier, the amount of damage the particle does depends on the energy. So again, he says this. The amount of damage depends on what you're hitting, frankly. And that's all. Some things don't like fast things, and some things don't like slow things. And that's just a truth. So the fact is you can find examples where you have to hit something with a slow speed and you can break it, and other examples where you hit it with a high speed and it doesn't do anything. So you can take the same energy and hit a surface over a wide area and accomplish nothing, or you can hit a tiny area and accomplish something. You can break one brick in an arch and the arch falls down, right? And you can put tons of weight on the arch and nothing happens. It just depends on what you're hitting. Obviously, high velocity impacts are more exciting to most material objects because it's harder to transfer the energy. The energy can't go from one place to another because the speed of the impact is so high. And so it starts tearing everything to pieces. But it doesn't have more material energy. Which is why a fired bullet, which carries most of the energy of the exploded gunpowder, so what does that mean, most? You mean 1,000 times more. It carries 1,000 times more energy. So even though there's a Newton's third law about some sort of equal and opposite reaction bullshit, somehow you don't care about that much. It does a lot more damage than the gun. So it really doesn't if you converted the energy. So if I take the gun and bang it into a lever, I can shoot a bullet. Simple fact. Okay, even though they have the same magnitude of momentum. They probably don't have exactly the same, frankly, but regardless, you just proved my point. If they have the same momentum, I just convert the momentum with a conversion device. And there's lots of them. Just like the basketball converts the momentum. I put other rubber balls on top of it and it converts the momentum. It puts the momentum into the lighter objects going much faster, and I'm making bullets out of guns. The basketball is a gun, and I'm going to make bullets out of the energy. Alright, so anyway, again, I appreciate this video a lot more than some of the others I've seen. Well, I don't really care. Okay, and I hope this response shows that I'm taking the argument seriously. Well, frankly, it doesn't. The obvious accusation is from 350 years ago is that you have a free energy formula, and in my opinion, you've done nothing to correct those arguments. You've not in some way debunked them as being untrue, that these scenarios are that I described would be the consequence of your theory, okay, put into those forms. So if I did make these devices, they will fail because your theory fails. The radio armor already fails. It fails to do what your theory says should happen. Okay. I mean, the irony is the absorbent side, I think, is the one that actually moves. So the reflective side is the one that's supposed to move. And it's the absorbent side that's moving. Okay. I am taking the arguments seriously and not dismissing them without reason. So again, the reasons really don't fix the problem. And they're really not honest to, especially the pendulum one. It's just not honest. If the object doesn't move, it can't transfer the torsion or the tension. So that's just bullshit. I'm not sure there will be I'm sure there will be disagreement and follow-up to my response, which I expect and encourage. Yeah, well, there'll be a point where there won't be any point, because you're just going to babble your way out of every one of these arguments, and you're going to lie about what the evidence shows. You're going to point to experiments and say they're good experiments when it couldn't be shittier. I mean, Gosling now and Despard, there's two completely shitty experiments. One of them so over-described, proof of kinetic energy, and the answer is as bad as you can get. Well, both of them have answers that are just as, the evidence is as bad as you can get for kinetic energy. No sign of it, really. And you're just playing a game that the momentum numbers are a tiny bit off, so therefore that invalidates momentum because there's a tiny difference. You have a gigantic difference between your prediction and the outcome of the experiment, and you're claiming victory. I mean, that kind of duplicity is so bad, you can't really get any worse than that. You're applauding experiments that are that backward and wrong and effectively a lie. So we'll see where this goes. Like I said, this is unfortunate, in my opinion, that he's still evading, and he's also doing it in this rude manner. So, but whatever. Just stick to the facts, ma'am. And I don't think you've stuck to any of them. So I've had no response to, in 350 years, I haven't heard one reasoned reply. They've had 350 years, millions of scientists, billions and billions of dollars, and they've never recorded it taking 4 times the fuel to go twice as fast. Something vital to economics. I mean, everybody should know this if it's true. If it's true that the faster you go 3 times the fast, you end up doing 9 times. You're wasting 9 times the gasoline. I mean, these are huge facts in terms of significance. And so not only is it for their own theory, they should shore this up with evidence. I mean, it's a bold statement to make. 4 times the fuel to go twice as fast. Bold statement. Not a single shred of direct evidence. Nothing. And then some of these little rickety experiments they're doing indicate it's not true, and they don't pay any attention to the fact that their conclusion is the further away. The ambiguity of the results is even more ambiguous for their conclusion. It's even more directly saying, no, that's not right. And they'll claim victory. I mean, duplicity. That's all this is. It's just gross duplicity. All right. I mean, they don't treat these arguments they're completely unfair. I mean, it's just a complete kangaroo court. They have no interest in the truth and are just looking for a technicality to escape. And if it was reversed, they would find that so offensive that somebody escaped the argument on a mere technicality, on some little bullshit. They're so duplicitous, they're so dishonest, they're so unfair. And they're just proving my points. Humans suck at being decent and honorable and having integrity. They suck at it.